Good morning to all. Today we discussed about the electric propulsion. The electric propulsion system are the heart of the electric vehicle. It consists of an electric motors, power converters and electronic controllers. The electric motor converts the electrical energy into mechanical energy to propel the vehicle. And also by using the motor we can produce electricity in the time of regenerative braking. During the braking time, the motor is acting as a generator. It produces the electricity that's stored in the battery. So the power converter is used to supply the electric motor with the proper voltage and current. The electronic controller commands the power converter by providing the control signal to it and controls the operation of electric motor to produce proper torque and speed according to the command from the drive. The electronic controller can be further divided into three function units: sensors, interface circuitry and processor. The sensor is used to translate the measurable quantities such as current, voltage, temperature, speed, torque and flux into electrical signals through the interface circuitry. These signals are conditioned to the appropriate level before being fed into the processor. The processor output are usually amplified via interface circuitry to drive the proper powertronic drives of the power converter. So this is the general diagram of our electric propulsion system. So the electronic controller receives signals from the electric motor, transmission speed, from the transmission wheel, from the speed, and also signals from the motor, signals from the energy storage. So in this electric controller we can use a software as a variable voltage, variable frequency control, field oriented control, static control, and also we can use a hardware processor, microprocessor, microcontroller, DSP and the power converter we can use a switches as a IGBT, MOSFET, GTO, MGT like that. And also in the motors we can use a DC motor, induction motor, SRM, permanent magnet, synchronous motor. Permanent magnet brushless DC motor also we can use. So the choice of the electric propulsion mainly depends upon three factors. One is the driver expectation, second one is vehicle constraint, third one is energy sources. The driver expectation mainly depends upon the driving profile, which includes acceleration, maximum speed, climbing capability, braking and range. The vehicle constraint include vehicle volume and weight. Depends on the vehicle type. The energy storage relates to the batteries, fuel cells, ultra capacitors. Differing from the industrial applications of motor, the motor used in EVs and hybrid electric vehicles usually require frequent start and stop, high rates of acceleration, high torque and low speed hill climbing, low torque and high speed and wide speed range of operations. So in the motor of electric and hybrid vehicle can be classified into mainly two groups, that is commutator motor, commutatorless motor. In the commutator motor we can have a separately excited, self-excited. In the separate self-excited we can have a series and shunt. Separately we can have a permanent magnet excited, field excited. In commutatorless motor we have an induction motor, synchronous motor, permanent magnet synchronous motor, switch reluctance motor, permanent magnet hybrid motors. So the commutator motors mainly are traditional DC motors, which include series excited, shunt excited, compound excited, separately excited, and permanent magnet excited motors. The DC motors need commutator and brushes to feed the current into armature, this making them less reliable and unsuitable for maintenance-free operation and high speed. And due to the technological development, the commutator motor is changed over to the commutator-less motor. In the advantages of the commutator-less motor, which includes higher efficiency, higher power density, lower operating cost. So they are more reliable and maintenance-free compared to commutator DC motor. So the commutator-less DC motor is more attractive compared to commutator DC motor. Next we go to the induction motor. Induction motors are also widely accepted in commutatorless motor type. This is because of their low cost, high reliability and maintenance-free operation. The conventional control of induction motor such as variable voltage, variable frequency control provide the desired performance. And the introduction of the power electronics and microprocessor era, the principles of field-oriented control and vector control of induction motor has been accepted. It overcomes the control complexity due to the non-linearity. So the field-oriented control still suffer from low efficiency at low light loads and limited constant power operating range. Next we move to the conventional motor of induction motor such as variable voltage, variable frequency cannot provide the desired performance. With the advent of the power electronics and microcomputer era, the principles of FOC has been accepted. The replacement of the field winding of conventional synchronous motor with the permanent magnet, the permanent magnet motors can eliminate conventional brushes, slip rings and field copper losses. So the permanent magnet synchronous motors are also called permanent magnet brushless AC motors or sinusoidal fed permanent magnet brushless motors. Because of the sinusoidal AC current and the brushless configuration. Since these motors are essentially synchronous motors, they can run from a sinusoidal or PWM supply without electronic commutation. When the permanent magnets are mounted on the rotor surface, they behave as a non-salient synchronous motor because the permanent magnet is similar to that of air. The permanent magnet being inside the magnetic circuit of the motor causes additional reluctance torque, which leads to facilitating a wide speed range at a constant power operation. And also we have a synchronous reluctance motors, generally simple and inexpensive, but with relatively low output power. Similar to induction motor, permanent magnet synchronous motors usually use FOC for higher performance applications and because of the inherently high power density and high efficiency. They have been accepted as having great potential to compete the induction motor for electric and hybrid applications. Next, by the inverting the stator and rotor of permanent magnet, DC motors, permanent magnet brushless DC motors are generated. The advantages of permanent magnet brushless DC motor is to produce a large torque because of the rectangular interaction between current and flux. This permanent magnet brushless DC motor generally operate with sharp position sensors. Recently, sensorless control technologies have been developed in the power electronics and motor drive laboratory. Thank you.